Alright, now let's get on to the Pythagorean identity, which is one of the things that you need to understand as mentioned in your syllabus. So, let's have a think about what we know about the unit circle and also about right-angled triangles, hopefully stuff that you have remembered or done so far in previous years. So, we know that sine theta is equal to y. We know that cos theta is equal to x. What we also know, right, is that when we're looking at something inside of our unit circle, and we're looking at an angle, we have a right angle triangle. As you can see, this length here is going to be y, and this length here is going to be x. And this hypotenuse is going to be 1. So what we can see from this is applying our Pythagoras theorem to right angle triangles, y squared plus x squared is going to be equal to 1, right? Because we have c squared equals a squared plus b squared. So, combining all of these three equations by subbing in sine theta for y and cos theta for x, we get cos squared theta plus sine squared theta equals 1. If you're having a look at the squareds, like in the middle, this is because conventionally, instead of writing cos of theta all squared, we actually put, or sine of theta all squared, or tan, or whatever, we actually put it before, like this. The reason we don't put it kind of just at the end of the function like this is because it looks like the theta is being squared, and that's not what we're saying. We're saying the whole function is being squared. So that's just if you're getting confused about that notation. And that applies for any trig function. So for cos, sine, tan, if you're in specialist, for sec, cot, etc. Alright. So before we move on. So this Pythagorean identity, as you can see, these two bottom equations are just this first one being rearranged. And what you can do is you can actually use this to find certain values. Right? So you might be given sine theta and asked to find cos theta. So you might be told the sine of a particular angle is 0.8. What is cos of that angle? And you can use this formula here to find it. We'll go over an example of this in a second, by the way, if you're getting confused. Alright, let's now get into the signs of trig ratios in the unit circle, and this also leads into finding trig ratios in different parts of the unit circle instead of just this first quadrant here, which is what we've been doing so far. So, we know that sine is equal to y, cos is equal to x, and tan is equal to x on y. That should be y on x. I wrote that wrong. So, when we're thinking about x, y, and y on x, we know in what quadrants they're going to be positive and negative, right? So, as an example, in this quadrant here, x and y are both positive, right? Because x is along here, it's positive, y is upwards, it's positive. So both x and y are positive here. If you're dividing a positive by a positive, you're also going to get a positive. So, all are positive here. sine is positive, cos is positive, and tan is positive. Moving around to this quadrant here, right? Here, x is negative, right? But y is still positive. So this means that the only positive value is sine. Moving down again into this quadrant, x is negative and y is negative, which means that both sine and cos are negative, but if you're dividing a negative by negative, you end up with a positive, which means that tan is positive here, and that's the only one. Moving across again, we have x being positive and y being negative, which tells us that cos is positive, y or sine is negative, and a negative divided by a positive is a negative, so tan is also negative, which tells us that the only positive value is cos. As you can see, we know which of the sine, cos, and tan are going to be positive or negative in which quadrants. You can remember this in several ways. Down here we have ASTC, which is just going in the regular order of the quadrants, all stations to central. You can also remember it as cast, going along in this direction. The other one that I have seen a little bit, and this is something that I believe the grade below us in my specialist class came up with, not myself, was all specialist teachers cry. So you can use that one as well. Alright. So let's move on to an example. So in this example here, we want to identify the quadrants where both cos and sine are negative, and then this is a question that I was talking about before, where we've been given if the function of theta is equal to cos theta, evaluate the function of negative 5 pi. So again, pause the recording, have a go at this, and then watch the solution. Right, so identify the quadrants where both cos and sine are negative. Applying our unit circle, right? When both cos and sine are negative, it is going to be down here. So it's the third quadrant, right? Because in that quadrant, the only positive one is tan, which means that both cos and sine must be negative. For our next question, if our function of theta is cos theta, we want to evaluate the function of negative 5 pi. So we're going to have the function of negative 5 pi is equal to the cos of negative 5 pi. Now, let's have a think about this. The first thing you always want to do is to, when you're finding like the cos, sine, or tan of a angle, is to draw a diagram. Always the first thing you want to do. So I'm going to draw a unit circle. We have negative 5 pi here. Because it's a negative, it means we're actually going to be going in the opposite direction. So instead of going anti-clockwise from the positive x-axis, we're going to be going clockwise. Because again, we have that negative out the front. So we're going to be going around this way. So this is 2 pi, 4 pi. So I'll draw that a little better. So we have 2 pi, 4 pi, negative 5 pi. So as you can see, we've gone around a lot of times, right? Remember, we know that each entire revolution is 2 pi, or like each half is 1 pi. So this is where we get to. Now what we need to think about is what is the value of cos at this point, right? What is the x value? Remember, cos is the x value. What is the x value at this point, right? So at this point here, what is the x value? Have a think about it. If we have our unit circle, I'll just draw it like this. If we have our unit circle in blue, what is the x value at that point? It is going to be -1 is 0 at that point, right? Because we have our x-intercept, which means that our answer is -1.